Welcome back, everybody, to part 2 of our Unit 5 review. When we last left, we were on question number 5, which again talks about equivalent numbers or equivalent fractions. So I'm going to underline that word equivalent. Which list has 3 equivalent numbers? Well, I know that 40% is equivalent to 4/10, because here's my decimal. In my 40%, I move it 2 places over, and I get 4/10. The question is 1/4 equal to 4/10? Is 1/4 equal to 4/10? And right now, that is not an answer. There is nothing I can do to multiply my 4 by to get 10. So I know that one's out. Let's look at letter B. Letter B says 25%, 25/100. I move my decimal 2 places over. 25/100, 25/100. I know those two are equal to each other. Now the question is, can I get 1/5 to equal 25/100? Well, I can multiply 5 by some number to get 100. And that's actually going to be 5 times 20 equals 100. 1 times 20 does not equal 25. So I know that one can't be right either. So let's take a look at letter C. 60%. I move my decimal 2 places over, and I get 0.6 or 6/10. I have 6/10 here. So I know my decimal and my percent. I'm kind of seeing a pattern here. My percent and my decimal are the same. The question is 6/10 equal to 2/6? Let's write that out. Is 2/6 equal to 6/10? Are these two the same fraction? Is there anything I can do to that 6 to make it a 10? Well, I could make my 2 a 6 by timesing it by 3. But if I times 6 by 3, I get 18. So it can't be that choice. That only leaves D as our answer, but let's prove that it's correct. 50%, 1, 2 equals 5/10, 0.5. 0.5, and I get 4/8. Is 4/8 the same thing as 5/10? Well, this one we got to think a little bit about. Okay, there's a couple of ways we can prove that this is correct. I can simplify 4/8. 4 goes into 4. I divide that by 4, and I get 1 here. I divide this by 4, and I get 2 here. So 4/8 is the same thing as 1/2. If I go over here, I can divide this by 5, and I get 1. And I divide this by 5, and I get 2. And 1/2 is equal to 1/2. That is why all of those numbers are equal to each other. That was a lot of work, but basically it's really just comparing, trying to make these all decimals, seeing if the decimal and percent are equivalent, and then seeing if the decimal and the fraction are equivalent. Okay? We could have also very easily have done this too for this last one. Let me just erase everything here because we know that those aren't correct. I'll even erase the answer here. We know that this is 5/10. I know that this is 4/8. I can change this into a division problem by doing 4 divided by 8. I put a decimal point here, kick it up into my answer, just like that. Can 8 go into 4? No, it can't, so I need to add a 0. 8 goes into 0 5 times, which is 40. And I subtract those two out, and I get 0. And I know 5/10 is equal to 5/10. So that's another good reason why those 3 numbers are all the same. Question number 7 says, which set of numbers below are in the correct order from least to greatest? And as I'm looking at these problems, I want to be able to put them in numerical order. So I look at this one, I say this is 0.35, that is fine, that's 35/100. 4/5, I say 4/5 really equals 8/10, which looks like that. And is 8/10 greater than 35/100? Yes, it is. The problem I get, though, is 8/10 is the same thing as 80%. Okay? And 9/17 is going to be less than half because 9 is just a little, or actually it'll be a little bit more than half. It's just a little bit greater than half of 17. So I don't believe it can be A. So let's take a look at letter B. 3/6 is the same thing as saying 1/2, which is the same thing as saying 50/100, which is the same thing as saying 50%. So is 75% greater than 50%? Yes, it is. So those two work. Let's check out this one. 2/10 is the same thing as saying 2/10, which is 20%. Is 75% less than 20%? No, it's not. These two are out of order. And it's actually, that one should be way over here. So it can't be letter B. When we look at this one down here, I have 15%, which is equal to 0.15. I have 1/3, which is equal to 0.33. And I know that one just because I know I can divide. I have 5/11. Now this one I'm going to have to divide. 5 divided by 11. Decimal point, add a 0. 11 goes into 55 4 times. That's 44. I subtract, or 11 goes into 50, I'm sorry. I subtract, and I get, what do we get? 50 minus 44 is 6. Add a 0, bring it down. 11 goes into 60 5 times, which is 55. I subtract, and I get a 5 here. Add a 0, bring it down. Now you can see it repeating all the way over. So it'll be 0.454545. That equals, we'll call it that, 0.45 and 0.80. So are these in numerical order? 15/100, 0.15, 33/100, 0.33, 45/100, 0.45, and 80/100, 0.80. There is your correct answer. All right. So there's problem 7. I think I skipped. No, I didn't. Problem number 8 says Ryder divides a pumpkin pie into 8 slices. He then eats 6 of those slices. So let's go ahead and get ourselves a pumpkin pie. So here's our pumpkin pie. We're going to divide that pumpkin pie into 8 equal slices. So we're going to say, I don't know, maybe there's 2 slices. There's 4 slices. There's 6 slices. And there's 8 slices. So there's our pie. We cut it up into 8 equal slices. So now what we got to do is figure out what fraction or what percent shows how much he ate. Well, he ate 6 of the 8 slices. So he ate this one, 2, 3, 4, 5, 6 of the 8 slices. Now there's a couple of ways I can do this. I can make it a fraction, 6 over 8, and then I can divide it. 6 divided by 8, decimal, decimal, add a 0. Say, okay, well, how many times does 8 go into 60? And that's going to be 7. 7 times 8 is 56. I subtract. I get 4. Add a 0. Bring it down. 8 goes into 40 5 times. So my answer should be 0.75, which I know to convert a decimal into a percent, all you got to do is move the decimal 1, 2 places, and the answer would be 75%. Now, if you didn't do all of the work here, what you could have done is looked at your picture graph that you drew. And I'm coloring in or eating 3/4 of that entire pizza. 3/4. I'm left with 1/4 left over, which means I ate 75% of my pizza. Let's go ahead and do the survey about Jack. Jack surveyed a group of students to see how many of them have a sibling. He then shaded the area on the grid. Oh, and this is the one our grid is really messed up. Our grid's actually down here. So we'll go look at that. Here's the grid. This is the grid we're talking about. That should belong up there. So the grid actually shows, that should be up here. The grid actually shows the percent of people Jack surveyed that have a brother or a sister. So it's the amount that is shaded. And if I were to count all these, this is 10, 20, 30, 40, 50, 60, 70, 82. That's 82 squares out of 100. 82 out of 100, which is 82 hundredths, which is that. And then we bloop it over 2 places, and it equals 82%. Okay? And then we're going to do number 10, and then we're going to take another break from this review. Part of this rectangle is shaded. Which number represents the shaded part of the rectangle? So I look at my rectangle. I have my hole as 1, 2, 3, 4, 5, 6, 7, 8 slices, and I've shaded 2 of those slices. So I would look at this and say, well, it's 2/8. The problem is I have lots of different numbers here that could represent 2/8. Well, then I would look at this and say, well, can I reduce 2/8 by dividing it by 2 and dividing it by 2? And I get 2 divided by 2 is 1, 8 divided by 2 is 4. Now I get 1/4. Is there any of these numbers that represents 1/4? Well, I know that 1/4 is the same thing as 25%. So there is my answer. When we get back for part 3, we are going to work on problem number 11 and a couple of the other story problems. Okay? So we got problem 12, and then I believe we have one more page, problem number 13. So we'll do that in part 3. We will be back after these messages from our sponsor. Have a good day.